Dora and I will start talking about the current status and a bit about the background of Many Babies 2. We will be doing this on behalf of the whole Many Babies 2 consortium. So we are addressing the questions whether children younger than 4 years of age have a theory of mind. This is a really quite ancient figure you see here on the left, but this is a quite robust finding when you use the standards Sally Ann false belief task that children around 3 to 4 years of age manage this task. Each dot is a study, and you see this quite consistent curve, and around their 4th birthday, children acquire a theory of mind. I can't see you. Let's try whether I can see you. Not is everyone familiar with the false belief task? I guess so. So I can skip that video, right?
Toby, you put now a big gray bar in front of your slide. You should remove it.
This is because I wanted to see you, but I'm closing it. Okay. It's also a quite bad example. It's really hard to find good ones, so I skipped that slide. So so far so good, but there is a bunch of literature out there, also old literature, that suggests that children younger than 4 years of age might have some earlier competence. There are some real-world examples you can see here on the left. If you played hide and seek with toddlers before, you might be surprised how bad they are at these hiding games. So that might cast some doubt whether they really have a full-fledged theory of mind before their 4th birthday. But so the question is that there might be something earlier. But how can this be tested in especially pre-verbal children or infants? This is why researchers came up with really clever tasks. You see here small kind of icons of these tasks. They can be clustered in 3 types of tasks. First one is violation of expectation paradigm, where someone has a false belief and acts upon it, and the children's surprise is measured. Then there is anticipatory looking false belief tasks, where you measure usually with an eye tracker, where children expect false belief-based action to be happening, and there are interactive paradigms where the children's helping behavior is the dependent variable, and it is tested whether they help this actor who is acting according to his false or true belief. And they found that children way younger than 4 are able to attribute false beliefs, which is the ultimate criterion for having a theory of mind, that they can do this at a very young age. That's nice, but there is this problem you are all aware of. In contrast to these original positive findings, there are now several partial or failed replications out there. It was really great to see in 2017. We had a symposium on, I forgot, SRCD somewhere, and the people from the audience were saying it's so cool that you give this talk about non-significant findings. This was something new in that field, I would say. But now there are many also published studies with failed replications. This here is the meta-analysis. On the left graph, you see big dots are studies with bigger sample sizes, small dots are studies with smaller sample sizes. You see the bigger the sample size, the smaller the effect. And I guess you are all familiar with these funnel plots, which here on this right-hand side shows you that there might be a publication bias at work in this literature. So there's especially on the right bottom original studies with small sample sizes who produce big positive effects, and the bigger studies with bigger sample sizes have smaller effects and not evenly distributed in this triangle. So what can we do? There are problems you're all aware of. It's hard to test these children, and you can't be mad at them because they are so cute. It costs a lot of time and a lot of money to do that. One solution to this empirical question would be to test a lot of children, and the answer is Many Babies project. Here in our case, it's Many Babies 2. We are currently more than 90 researchers from 25 countries, 5 continents. We have people from different theoretical camps on board, which is really good. And it took us 2 or 3 years to design this task. We are now using for our first study. And here are the people who are the leads, but there are many more who are doing a lot of great work. I don't have to show you how we work because this is a big team science conference. You know how this is done. This is just to show you. We are, I guess, like you, using a lot of Google Docs. The good old mailing list is quite good. We have many dead Slack channels. This never worked out for us for some reason. I don't know why. Let's see how this goes. We used Zoom before it became mainstream. And we have regular presentations at symposia and conferences where we report the current status of the project. And now I hand over to Dora.
Yes, thanks, Toby, for introducing the project. To begin with, we decided to choose a paradigm that is the easiest to scale up into many labs. So as Toby introduced the different findings, there's actually both behavioral tasks, looking time measures, various types of measures that the so-called original tasks on infant theory of mind used. So we chose eye tracking as the first one because we figured creating videos and sending them to the labs or the different labs is the easiest way to get things going in a standardized way. And so we took stimuli from earlier studies that probed theory of mind in infants. And Toby, can you play the video? So we designed these stimuli together in a collaborative way. And as Toby mentioned, it took some time, but I think we're quite happy with the outcome. So in this video, there are these 2 characters and they're chasing each other. You can probably hear the little sounds they're making. I find it annoying. The babies love it. So it's a success so far. After this chasing event, this mouse character always goes into the tunnel and appears on one side of this Y-shaped tube and goes into one of the boxes. So afterwards, the bear follows. So this kind of chasing continues, and the question is, where will the bear come out of this Y shape? And so what you see here now is what we will call later a familiarization trial. We familiarize infants with this scenario, and we plan to use this setup to then probe whether what are infants' expectations, where these characters should come out, where the bear in this case should come out. Toby, you can continue. Currently, what we have so far on is a pilot study. In this case, it was a subset of the labs that participated, but even like this, we have a quite a neat sample. And we played this video that we just played, that you just saw. We played it to these toddlers, and the question was, do we see any kind of anticipation? So what I mean by this is there's a phase where the bear goes into the tunnel and we expect it to come out somewhere. You can even hear little footsteps in anticipation that it will come out. There's a 3 or 4 second period where it hasn't come out yet. So this was kind of a proof of principle. Can we elicit goal-based anticipation? So do they, before the bear comes out, expect it to come out on the side where the box with the mouse is? And the reason why this was important to establish, first of all, it's new stimuli. But second, actually, many of the failed replications recently did not find belief-based anticipation, but not even goal-based anticipation. So they kind of failed at the proof of principle stage, whether it's because stimuli were not engaging or anything else in the stimuli or in the paradigm. But then it's also harder to draw conclusions about whether infants would understand complex mental states. So what you see here is in the anticipation phase, there's a higher proportion looking to the target, to the correct box. And so we were quite happy with this outcome. We fine-tuned it a little bit with a follow-up, but decided to go ahead with this design. You can go. So currently, we're running sort of a proof of principle study. We're not contrasting true and false belief as many of the studies do, but we start with knowledge versus ignorance. So this is a character who knows where the mouse is or does not know because just wasn't there in any of the hidings. So the mouse relocates halfway, but in the ignorance case, the bear will just have no idea where the mouse is. So we're hoping to sort of establish this very simple, has seen it, will go to where the bear is, versus hasn't seen anything, then they look at random pattern. And this is what we are probing now. So we have submitted this study as a registered report to the Journal of Child Development, which was accepted. And we begin now the data collection phase, have spent the last half a year preparing lab manuals and eye tracking projects, which were now sent out. And we plan to finish data collection until next summer, but also prepared to adjust to each lab's pace. At the moment, 60 of them are signed up. So if all goes well, then we will have almost 1,000 children and almost as many adults included. We were very grateful for previous projects, in particular Many Babies One, but also others that had some of these procedures set up that we implemented in MB2 as well. For example, asking them for a lab video before they start data collection and piloting the stimuli, because to see if they work in their setups. And in the spirit of always preparing for the next phase, we added the pilot sort of additional test trial with pupillometry as a potential pilot for follow-ups. Yeah, so you can see the authorship list is long and it's growing, and we are still looking for collaborators. So if you're interested, get in touch. You can see our email here, join the mailing list, or check out the website for further information. Thank you for listening.